Alright, in this video we're going to be given a description, and then we want to shade all of the numbers that fit that description. So the first one says shade all the numbers that are rational numbers. So anything that's rational. Rational numbers are decimals that repeat, decimals that stop, and anything in a smaller subset. So any integer, any whole number, any natural number, those are all rational numbers. So all of these, you have to decide on the simplest form first. Try to figure out what is -1 divided by 11. That's 0.090909 going on forever. We want to decide on this number, not necessarily the fraction as it's written or the square root of 5. We want to figure out what does this equal, and then decide, is that number going to fit this description? So is a 0909 a repeating decimal a rational number? That one's true. All repeating decimals are rational. So that's a rational number. The square root of 5. 5 is not a perfect square. When I say that, I really mean when we do the square root of 5, we get a decimal. It's 2 point something. It actually doesn't matter. 2 point something going on forever. It's going to be an irrational number. It's not repeating, and it doesn't stop. Anytime you do the square root of a non-perfect square, it's going to be an irrational number. -2.5 minus 1.5. That would give us -4. The best description for -4 is really the integers. But all integers are negative numbers, so but all integers are rational numbers, so we can shade that one. It's an integer, which means it has to be a rational number. The next one is 3.2496. That 3 dots, the ellipse at the end of that, tells us that that number is going on forever. It doesn't look like there's a pattern. 2, 4, 9, 6, those are all different. That's an irrational number. It's a number that goes on forever, and it doesn't repeat. The final one, -1.353, that decimal stops right there. That is the last decimal place, meaning it's a rational number. Decimals that stop are always rational. Alright, the next one's asking us to shade all numbers that are integers, but not whole numbers. So the integers include all of our positive and negative whole numbers, all of our positive and negative non-decimals. When I say I don't want a whole number, that means I'm basically just talking about the negative whole numbers, the negative ones that don't have decimals. So in that first one it says the negative square root of 1. That is just -1. The square root of 1 is 1, and then we apply the negative sign. It's a -1. There's no decimal part, so it's still an integer. But we have a negative sign, which means it's not a whole number. That fits that description perfectly. It's an integer, but it's not a whole number. 9.0 is really just 9. That's an integer. There's no real decimal part. We don't really even need to think about this 0.0 part, but it's also a whole number. Whole numbers include 0 and the counting numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. That's included in our whole numbers. So we do not want to shade that one. It is an integer, but it's unfortunately also a whole number. The third one is 3 times 1.5 squared. We're going to follow order of operations here. We do the exponent first. So we do 3 times 1.5 squared is 2.25. And when we multiply that, that would give us 6.75. This decimal part means that's not an integer. It doesn't fit that first part of the description. It's not even an integer. It's also not a whole number, but it's not an integer, so we can rule that one out. 0 is a whole number. It's the best description of a whole number. So while it is an integer, it's also a whole number, so we won't shade that one. -21 divided by 7 is -3. That's a negative number, and it does not have a decimal part, so it's an integer. And it's also a negative number, so it's not a whole number. That one can be shaded because it's an integer, but not a whole number. The last one's asking shade all the numbers that are real, but not rational. Real is the description of all the numbers that we've learned so far. So that really isn't too constraining. It's basically telling us find the numbers that are not rational. Basically all that's saying is find the irrational numbers. Anything that's a decimal that goes on forever and it doesn't repeat. It needs both of those things. It can't stop and it can't repeat. So I'm going to rule some out right away. I see that this one is repeating. I'm going to rule that out. I have a repeating decimal. This decimal stops. I can rule that out. This one's a fraction. I can rule that out right away. All fractions are rational. This is going to be a repeating decimal. That's like negative 1.090909. It's a repeating decimal, which means it is rational. We're looking for the ones that are not rational. The square root of 2.25 is 1.5. That's a decimal that stops right there. That means it's rational. The square root of 50 is 7.1, going on forever. There's more digits after that, but it goes on forever and it doesn't repeat. That's our only irrational number. It's irrational because the decimal goes on forever and it doesn't repeat itself. It's real, but it's not rational.